Okay, hi, this is Chapter 2, Section 2, and what we're talking about here is adding, thought I had a pen, adding and subtracting radical expressions. Okay, so there's something that you need to know probably before we start doing this. In the last section, we talked about reducing a radical, but what we didn't talk about is what happens if there's a coefficient on that radical. So for example, if we were to have something like 6 times the root of 32. Okay, well, let's reduce the root of 32. All right, and we're going to do that by breaking this down and going, I'm going to just go with 8 and 4, right, because that would be our normal ones. So 4 and 8. And then here's where I'm going to start taking some shortcuts, okay? The root of 4, I know, is 2. There's 2 2's as a root of 4, so I'm going to just take it out of the root and do that. If you need to, do this. Rad 2 and rad 2 and circle that and make the 2, then do that. But if you know some of your square roots, then you can just make the whole number, right? So the root of 4 is 2, the root of 9 is 3, the root of 16 is 4, the root of 25 is 5, the root of 36 is 6, is 6, the root of 49, you should know all these by heart. The root of 64 is 8, the root of 81 is 9, the root of 100 is 10, the root of 121 is 11, the root of, 144 is 12, 13 is 169. You should at least know up to there, if not up to 15, okay? And that will make your life easier. And also, we're going to go back to this in a second, but the root of 8, you're going to see that a lot. And that's going to be radical 2, radical 4. Well, the root of 4 is just plain 2, right? So this is going to be 2 radical 2. And if you can commit that to your memory, that the root of 8 is equal to 2 rad 2, then when you see something like this, you can just simplify it and go 2 rad 2. I do that in my brain all the time. So now you would multiply these, right, and get 4 radical 2. But now you need to take this coefficient out front and multiply it by the coefficient you get out front when you simplify. So this is actually going to be 24 radical 2. Okay, so if a number's out front, it's going to always stay out front. It can't ever go underneath a radical. And when you simplify and bring a number out in front like this guy, well, it's going to now stay out front. And when you're doing a factor tree, you're always multiplying in a factor tree, right? So it would make sense that those things are going to get multiplied. So this is a skill that you're going to need to know when we move on to adding and subtracting, because you're going to see a lot of these coefficients, a number out in front of a variable or a radical, when we move on and do these. So I'm going to go and give you a couple of pieces of information and then do a couple of examples for you before you're ready to go on and try a couple of these on your own, okay? So here is an example, and we'll do one that's got like radicans right off the bat, okay? So this is 8a radical 7 minus 4a radical 7 plus 6a radical 7. So notice a couple things here. The radicands are all the same. Remember that a radicand is the number underneath the variable. Okay, if that was not the case, and if they were not simplified, you would need to make sure the first thing you would do is to simplify any and all radicands. Okay, in this example, they're already simplified. Then, in order to combine like terms, just like with variables, you can only combine like terms if the radicands are the same. Okay, so this is important. All right, and then you would just add and subtract the coefficients out front based on the signs. All right, so this one's got a radicand of 7. And if you think of these like variables, like this is exactly the same as 8a, and this is like a b, right? So this would be like a b, then minus 4ab plus 6ab. They're exactly the same as a variable. This would give me 8 minus 4, combine these, you'd get a 4ab, and then I'd add a 6ab, and that would give me a 10ab, okay? Well, if I think of these in radical form, and that b is really a radical 7, these two give me a 4a radical 7, right? So I have a 4a radical 7 plus a 6a radical 7. Then I combine these, and I'm just adding these terms out front, so that gives me a 10a radical 7. You never change this term, right? It's staying the same when you combine like terms, just like a variable would. So you keep that value the same, keep it under the radicand, and all you're doing is adding or subtracting the terms out in front, okay? So 10a radical 7, that's the answer to this. All right, let's take a look at another example. And this one will have different radicands. Okay, so this one is 3 radical 50 minus 2 radical 32 plus 4 radical 20. All right, so think of these as completely separate problems, okay? So I'm going to kind of draw a line. Let me change this to black. I'm going to draw a line down between each of these and solve these all completely separately. So if I were to deal with the 50, I'd go rad 25 and rad 2, and this is just a 5, right? A whole number 5. And so I would multiply these two values. We're going to multiply those. So this is going to give me a 15 radical 2. And then this guy, oh, I want to do a different color, something distinctly different. Okay, so 32 is going to be, and I'm trying to think of perfect squares, and the larger the better. So 32 is 16 times 2, so rad 16, rad 2. This is just a 4, so then I can multiply these two together, and this gives me 8 radical 2, and then 20 is radical 4 radical 5. Okay, so this becomes a 2, so I'm going to multiply these two together. So this is 2 radical 5. So when I look at these terms now, these two are like terms because the radicands are the same, but this guy is like an odd man out, right? So I'm going to have, excuse me, two completely different terms in my answer. So if I bring this minus sign down, I'm going to have 15 minus 8, and that's 7 radical 2, and then bring this plus sign down, and then I'm going to have a plus 2 radical 5. And this whole thing is my answer. And a lot of students don't like these because they're not really checkable, so to speak. But that's what varsity is going to do for you. You'll put that whole thing in varsity, and it'll check and let you know that you're correct. Okay? All right. So another example. Let's do one. So remember, you've got to make sure you simplify your radicands first. Okay, another example. Let's do the root of 180 plus the root of 180 plus the root of 45. Here's an example where I might not simplify first, okay? So sometimes you have to think outside the box a little bit. These two have the same radicand, so I can add those together right off the bat, and there's an invisible 1 in front of each of those, right? So now I would get 2 rad 180. The radicand stays the same. And then I'll just bring this down. So I'll go plus rad 45. And now let's simplify and see where we end up. So I'm going to do this guy. 180, so I'll do 18 and 10. This guy's going to be rad 9, rad 2, rad 2, rad 5. And the reason I'm putting the 2's next to each other is because those are going to give me a 2. This is just a 3. So these will get... And this guy is going to come down here. So 2 times 3 times 2, and this radical 5 is left over. So I have 6, 12, 12 radical 5. Bring the plus sign down. I'm going to do this one in a distinctly different color. So this is going to be rad 9, rad 5. The 9 is a 3. So this is 3 radical 5. My radicands are the same. So they are like terms. So all I'm going to do is add or subtract based on my signs. So 12 plus 3 is 15 radical 5. Okay? That's how I would do that guy. All right, and one more just to do some crazy variable stuff, because you're going to have some crazy variable stuff. All right, this example looks like this. 8 cube root of a to the 7th b to the 6th plus 2a squared cube root of a b to the 6th. So first, let me say you can't add radicals that have unlike indexes, okay? So the first thing you have to do is make sure that these are like. Okay? If they're not like index, you cannot combine. Okay, so that's the first thing you have to know. So we're going to simplify these, and we didn't do, I kind of went pretty quick in the video yesterday. You should have covered this in Algebra 2, so it's review. But really you can divide these powers, right? So if I have a to the 7th, I have the cube root of a to the 7th. I can divide this 7 by 3, right? So I have 2 groups of 3, like a to the 6th means I would have a squared. So I would have 1 left over. So a to the 7th, if I were to divide by 3, I would have a remainder of 1. And that's the 1 that stays under the radical. So I would have a squared out here, cube root of an a underneath, right? So I get 2 groups, a, and another a, and those are the 2 groups that come out front. And then the leftover one stays inside. So if you need to draw them all out, that's fine. But if you just know that you're going to get 2 groups that are going to come out and one's left over, that's fine too. However you want to do that, you know, like I said, and you can shortcut things for yourself and make things easier. So I know that this is going to be, when I take these out, I'm going to get an a squared outside, and a b to the 6th will also give me a b squared outside, and then a cube root of a. No b's are going to be left over because 6 divides evenly by 3, right? So there's not going to be any left over, and the 8 stays out there. This guy over here, this a can't come out because there's a 1 on here, and this power is less than the index, so I can't get that out of there. But this b to the 6th, I can get 2 groups out, so I'm going to go 2 a squared. The b squared is going to come out. Then I have the cube root of a that can't come out. Okay, so now what has to happen for these to add together is these variable terms out front have to be identical in each term, and they are. Then your index has to be the same, which they are. And then your variable terms have to be, and your radicands have to be identical. And they are. So all those things have to be true. So to combine like terms, one, the variable coefficients must be the same. Two, the index must be the same. And three, the radicand number and variable combo must be the same. And this is not an or, this is an and statement. All three of those things have to happen in order to combine those like terms. Okay, and that does happen in this problem, right? Here's the variable coefficients, a squared, b squared. The index is 3, and the radicand is an a. So I can now just combine my coefficients out front, which in this problem, I have an 8 and a 2, so I'm going to get a 10. These don't change when I combine like terms, so I get a squared, b squared. I have to put my cube root in, and then the radicand stays an a. So this is the answer to this problem. Okay? And I think if you can do all that, you can handle these problems. Just watch your signs, all right? It's also fine if you have, this can be a negative, right? The answer can be negative. Okay, so just be aware of that it can be negative, depending on the signs of the problem, okay? So that's it. Toodaloo for now, all right?